Hi there, I'm Paolo and one of the developers of RoboSim, which is in beta right now. I'm sorry, I'm deeply congested with strong A fever, so my voice is not the best, and I'm also sneezing occasionally. But this is the main game that you can install for now is Windows. And if you go on the main menu, you have the job board, the garage, telemetry, additional challenges, and the sponsors. So the idea is this game is that we are going to have different uh, physics simulators that include a real robot, and the user needs to solve specific tasks. And when you solve this task, you're going to be rewarded in terms of dollars. I mean, real dollars that is offered by the sponsors or whatever company want to offer some price for this one. Okay, so let's kind of show you how does it look like. So in this case, I have some jobs, none in progress, none completed. Let's start with something simple. So for now, I got $150 in my account and a 4-star performance. So I'm going to do this again. Okay. So in terms of controls, you can have the keyboard or you can have an Xbox controller, which is the one I have now in my hand. I feel this is more intuitive because I'm also a gamer, and we made a lot of efforts and a lot of improvements in the inverse kinematic so that it feels natural. It does have human constraints, so you don't end up in singularities and any other weird positions. So it makes it really easy for the player. So this is a very vintage room that we put together. There's a soda can, and that's my universal robot. What I can do is, if I'm in the universal coordinates, everything I do now, so if I'm going forward, is going to that axis, and backward is going to the same axis. If I go in left, it's going to go relatively to that. So this is interesting, but what you really want to do is to go into camera mode, because that's where you have a real perspective. Like if you are training an AI model, you need to be able to see this from the actual gripper. Okay, so when you go into gripper mode, you are essentially controlling everything as in you were in a first-person shooter FPS game. And you have all the 6-axis controls, so you have 3-dimensional, XYZ, and roll pitch yaw for the effector. It's kind of like a video game, more like a plain video game, where you have all these 3+3 controls, plus the gripper, so I can press the gripper and release. We also have rumble feedback, so in the next release, when you grip, you're going to get the actual force feedback, but it's not now. So to get that thing, what I have to do, first of all, I need to get my bearings. So I would say I personally prefer to rotate the camera so that I'm facing where I'm looking. And I then angle it a little bit, and I'm going to move in that direction. So it's very important to avoid these weird positions if you can, and the player needs to learn that. But yeah, let's see if I can get it like this. Maybe the yaw, like I can also adjust my yaw so that it's like a little bit better. And the red warnings is where I'm getting close to a singularity point, so I want to avoid that. So I got my can. Now it's very important. This is full physics, so it will drop if you're not careful. So you want to, and I'm still kind of learning myself. So if I drag it going back, that's my phone, ignore that. I can go back and I can start to move it. So I'm still within this orbit, which is the achievable space. And let's see if I can go there on the other position. Okay. There we go. It takes some time, but eventually we learn how to move the arm. Okay. Then I'm going to adjust this a little bit higher. And here, I'm going to drop it here. And you get your stars based on the performance. Of course, the task gets more complicated. So if I go to another one, unattended, let's say job 0 is job 3. Let's see, did we do this? Yeah, so you have more objects and some of them are on a table, right? So let me try this again. So this looks kind of easy. Wow. Let's try to get this one. So I get the can. We do have some clipping problems, which we're going to fix. And the problem is there is a table there, so it's really hard. You really have to learn how to do that. And let's see. Let's see. And so the table is here, and yeah, I have to be very careful not to hit it. And yeah, you can see it's kind of a challenge because see if I can go on the top a little bit. Yes. And maybe I can go on the other side. And I gave up on the red one. Let's try the green one. Okay. And really, this is really to explain, like, to see how difficult it is to do these things, because even on real arms, it's really, really difficult, right? And it's also like to show that there is limits to these things. And everything we do during these sessions is recorded so that you can train your AI model. Where is the other can? I think I dropped it. Oh, here we go. So this one, for example, is a bit of a challenge because the arm is getting near its singularity. So the way I do it is usually like that. Ah! And maybe I rotate a little bit. So see, the physics is okay. And now I have to go back. Oop. Let's see if I can. Yeah, I was kind of lucky there. And yes, one of the advantages of this system is that we record everything, like even pictures, and any any forces. So like if you're damaging your robot, it's all recorded, right? Just besides the performance. And wow, it was upside down. I don't know how many paints I got from that. And if you ever get like there's points where you might get confused, you can also hit home and you can go back to this position and go back. So I hope this explains the game. And we're looking for sponsors, especially from vendors of robotic arms, but also companies that essentially wants to collect data. So the idea is that everyone, once we release this game, everyone will be able to play it on like a full physics simulator, and will be able to essentially be rewarded by generating this data set. So in the next one, I'm going to show you a little of the hardware we are developing that also connect to this game so that you can essentially have a more seamless experience when you're actually using an arm that replicates the same behavior of the one you see on the screen. So thanks for listening and see you soon.